shall start off with the introduction. The rate of individual losing a limb is increasing due to congenital defect, which is present during birth. It is lost during war injuries, accidents, as well as diseases. The amputee can adapt to a normal life with an artificial hand. With the help of an artificial hand, it can carry out daily activities such as grabbing objects, writing, dressing up, and for my case, typing. So the objectives of my project is to be able to determine the placement of the sensors of the muscle, where to place the sensors from the forearm. After finding the location of the sensors, location of the placement, these signals will be analyzed to obtain the highest performance in order to control the prosthetic hand. And lastly is to develop the program to control at least 2 fingers for typing purposes. For my case, it's been controlled for the index and the middle finger. As for the literature review, this is the MyoAware muscle sensor right here. The MyoAware muscle sensor is what I will be using to detect the EMG signal from the muscle. It is formed by the movement of muscles. The brain transmits electrical signals to the muscles whenever an individual thinks about flexing a muscle. Once this signal has been transmitted to the muscle will react, and the forces behind the muscle, the fibers will be pushed forward, the muscle fibers. So the higher the muscle force, the higher the muscle fibers are utilized, and the greater the EMG signal is produced. Based on this literature review, it shows the location of the electrodes. This is for an intact limb subject, where, as you can see in figure A and figure B, shows the location for a person who is not amputated. As for figure C and for figure D, it shows the location of the electrodes for the amputated person in order to control each individual finger. Here are the samples of their results. As for A is the results for the intact limb person. As for B is the results, EMG data results for the amputated person. These are the study on previous research that I have found. We will start off with the rehabilitative robotic glove. Based on this project, I was able to apply on mine the usage of servo motors. Based on the rehabilitative robotic glove, it has cables attached to the glove, where these cables will be pulled or rotated by the servo motors, which will then contract the glove and expand it as well. That is one of the things that I have applied on my project. As for the bionic hand, based from this project, I was able to apply the functionality of the robotic hand, the artificial hand. For example, to be able to control 2 individual fingers independently in order to type and also to hold objects. Based on the bionic hand as well, I also applied the durability of this product. It is able to withstand a force for up to 50 kilograms. As for the Enable limitless arm, based on their project, I was able to apply the drawing and the design of the prosthetic hand. Enable has made countless numbers of prosthetic designs for amputees. So based on their project, I was able to learn how to draw and design the artificial hand and the arm. Here I shall explain the method of my design on creating the prosthetic hand. First off, we will start off with the EMG signals, where we have to find the location on the forearm of where the highest or the finest EMG data will be present. After finding out the location, this EMG data will be collected, and the signal will be filtered and the noise will be reduced by the MioWare muscle sensor. Then the output data from the MioWare muscle sensor will be output to the Arduino Uno, where Arduino Uno will be recording the data in a serial monitor. Before I continue to the next stage, as for the artificial hand, the drawing of the artificial hand will be done and it will be 3D printed using ABS material. After the material has been printed, it will be assembled together with the servo motors as well as the nylon string to pull down each finger by using the motors. Once I am able to finish the assembly, both the data of the EMG and the assembly will be integrated together, where the signals of the EMG data recorded will control the artificial hand. Here are just the example of where the position of the MioWare sensor will be placed to test for index finger and for middle finger. On the left side, you can see it is placed at the palmaris longus of the muscle, where it will detect muscle activity from the index finger. And as for the right, the MioWare muscle sensor is placed on the flexor carpi radialis, where it will detect motion from the middle finger. Here is the final assembly of the artificial hand, where there are 3 motors which will control the index, the middle finger, as well as the ring and pinky finger respectively. The 4th servo motor, which is in the palm, will be controlling the thumb independently. Here are the presentation of data. So we start off with the index finger. EMG data was collected from the top, which is position 1, middle, which is position 2, and bottom, which is position 3 of the palmaris longus muscle. Based on this data, as you can see at the top position, the data was only able to reach up to above 500 data bits. As for the middle, it was able to reach almost 700 data bits. And as for the bottom position of the palmaris longus, it is able to reach almost 600 data bits. Now, as for the EMG data collected for the middle finger, where it is placed at the top, which is position 1, middle, which is position 2, and bottom, which is position 3 of the flexor carpi radialis muscle. In position 1, which is the top part, it is above 650 data bits. As for position 2, which is at the middle of the muscle, it is almost 500 data bits. And as for the position 3, which is the bottom of the muscle, the highest that it could reach for the EMG data is slightly above 500 data bits. Alright, so therefore, based on the 3 positions that was taken, top, middle, and bottom, for both palmaris longus, which is for the index finger, and for the flexor carpi radialis for the middle finger, it can be determined that the position with the finest and the highest EMG data, we will start off with the index finger. The highest and the finest EMG data is from the middle, which is position 2 of the palmaris longus. As for the middle finger, the finest and highest EMG data is located at the top position, position 1 of the flexor carpi radialis. So these 2 positions will be used respectively to control the index and the middle finger of the artificial hand. So in conclusion, the location of the placement of the MioWare muscle sensor has been determined. The artificial hand is able to flex and extend the index and middle finger. It is also able, with an additional feature, it is also able to flex all 5 fingers at once. This is by setting a command when both sensors are turned on, it will flex all 5 fingers at once in the form of a fist in order to grip on items or carry or lift up items. Lastly, the artificial hand does not require any surgical procedure as it is a non-invasive device. That will be all. Thank you. Here I shall show you my design of the artificial hand which I have with me. This is the end of my presentation. Thank you. At the end of this, I'm going to be showing a short demonstration video of how the full functionality of the artificial hand will be used. Thank you.